Okay, this is problem 58 from chapter 7, and it's a big problem, so bear with me while we work through this. Hopefully I can explain it well. I've tried to draw a diagram here so you can tell what's happening. We have this truck that's coming down this hill with a length L, and then on the other side there's kind of like a runway ramp with length X that it runs into and runs up, and we have these two different angles, alpha and beta, between these two ramps here. It's wondering what is the distance that the truck will run up this ramp before coming to a stop. And so we have several different equations we're going to be using. We're going to use the kinetic energy equation, potential energy equation, and we're just going to find an equation that we can use to figure out that that distance. And we're given that there's a coefficient of friction. Let me make sure. Yeah, there's a coefficient of friction with it's represented by the mu, r or whatever. Anyway, so we're going to just start plugging away at this. So first we have our initial energy minus our work is equal to our final energy. We're going to say our initial kinetic energy is equal to 1/2 mv sub 0 squared, and our final kinetic energy should just be 0. Our initial potential energy is mg, and our initial yi, we're given that here. If you see, we're just going to call this distance here y sub I for our initial height. So that's why we get our potential energy is equal to mg of that height. Our potential final energy is going to be mg x sine of beta. And hopefully you can see why. We have mgx, which is this distance, sine of beta, which is that angle. That's our final potential. Okay, so with that, we're going to say that our yi equals L sine of alpha. And hopefully you can see why that is as well. We're finding this distance here. So yi equals L, which is that whole distance, sine of alpha, which will give us our yi. Next, we have our work equals Fx. Our final force is equal to mu of Fn, which equals mu mg cosine of beta. So it's a little bit confusing, but our final force is mu of Fn, which is mu mg cosine beta. And then, there's so many equations for this, but the final one that we need is our work is equal to mu mg cosine beta times x. Cosine beta x. This bottom. So add all these together, and I think I'm going to have to erase some so that we have room. But we basically connect, just so you know what I'm going to be doing, we're going to set all of our initial kinetic and potential energies equal to our final kinetic and potential energies and see what we come up with. So let me just make room because it's a pretty big part to this. So. So here's what we're going to do. We're going to take all those equations that we just figured out, and we're going to say Ki plus Ui minus W equals our kinetic final plus our potential final. Then we're going to have to do a bunch of simplifying and stuff like that. Let me write out the whole thing. Okay, so once we've written it all out, we have this huge equation, 1/2 mv0 squared plus mg L sine alpha minus mu mg cosine beta x. That's all for the initial energy. And that's all equal to 0 plus mgx sine beta. Now we're going to simplify. Okay, so the first thing we can do is cross out the m for the mass across the entire thing, and we get just the same equation with all the masses gone. The next thing we can do is get rid of so the next thing is we're gonna add this part, because we're doing all this minus that, we're gonna add that part over here, kind of to get common variables together and stuff like that, and we'll come out with another equation. Okay, now we have 1/2 v sub 0 squared plus gl sine x, and then we were able to, from this previous problem, we were able to pull out an x and just have mu g cosine beta plus g sine beta. And we kind of have these things grouped together. And now finally, we're going to solve for x. And if we do that, we'll get our equation here. Okay, here's the final result. We have 1/2 v sub 0 squared plus g L sine alpha, all divided by mu g cosine beta plus g sine beta. And if we were given numbers for all these different variables, then we'd be able to just plug into this equation, and that would give us the distance the truck would travel across that. Hopefully you can see that fairly well. And that's all from this whole diagram we're given.